So now we can begin to solve that, right? We know what, well, we can plug in values, right? Because we know what K1 is. And we know what K2 is, K3, and we have those values, so we can put those numbers in there, right? So, so if I do, so that one will be what? Oh, and we'll just do this. We'll put a scalar out front. Now we can solve. And if you have your TI 36X Pro, punch numbers in and it'll spit it out for you, right? So U2 is going to equal minus 2, 3, inches, and oops, E2 equals 0.01249 inches. Okay, so those are our deflections, right? So if I want to figure out the stress, how am I going to do that? We can go back to this, correct? Right? Because we know that information. What? Let's see. So stress in 1. We know stress is P over A, but we're defining P as K delta, right? And let's see. This was 7.5 times 10 to the 5th. Pound inches. And this is the stress. So this would be element 1 minus 0.0008 inches. Now divided by, this one was 1.5 inches squared. So sigma 1 is going to equal minus PSI. That makes sense? Questions? Adam and Chelsea are completely confused.
That's okay. It looks like we're going to start a new something soon.
So the last matrix you made,
Uh-huh.
the 10 to the 5 0 in front of it?
Yeah, this guy?
Yeah. So are those just the values you got from plugging in the K values to the matrix above?
Uh-huh. So the K values that we got from here, So this plus the 0.36K3 should be 9.66 to the
So,
6.
so where did the negatives come from? Should we have been negative on the matrix before that?
Oh, did I I'm probably miswrote. Yes.
Okay.
Sorry. Yep. There should be negatives there. I apologize. The other reason why you don't want to write these out. Well, yeah, I mean, you have to be very, what's the word I want? Very focused, very detail oriented. Anyway, it's just, yeah. It's a lot nicer when the computer does it. Okay, so what are we going to do for sigma 2? What's that going to look like? What values should I plug in for our equation there?
Our K2 value is 2.5.
2.5. Okay.
And the delta is B2.
B2, yep. So we're going to be 0.12419. And our area was 1 inch squared. So sigma 2 gets PSI. And then finally sigma 3. Let's see, so this was 6. And okay, so here's my picture. We're looking at element 3, right? Okay. So we did the 2 axial ones. So now this one's a little trickier. So this is what, our cosine times 0.00438. Actually, I'm going to do this. Start over here. So our cosine times 0.00438 plus sine times 0.01249. There we go. Which is 3 equals 6.9 PSI. There we go. So now when we do it in Patran, we should come up with those deflections and those stresses. Okay. So shall we give that a whirl and see if we can do that? Get your computers out and we'll walk through it and see if we can do that. And this will be good practice for you guys working with the Nastran or the Patran. I mean, it's kind of cool what you can do and how all that works, but it's just really tedious and laborious working through it by hand. Come on. So now, if we do it with the computer, it should go a lot better. So I'm going to switch to the laptop. Okay, so you guys have your books, so you know what the picture looks like and what we're dealing with. In here or not? Too much in the way for what's going on. Maybe I'll try sitting down a little bit. Come on. I guess it's stuck up. Okay. Come on, think faster. I probably started two of these. Oh, yeah. Freaking out. I'll print the notes and post that stuff for you guys so you can get caught up. There we go. Okay, so new. Oh, and I figured out how to do the label thing too. Oh, I wonder if I should start a new one. Sure. Default. Okay, so first thing we do is what? What's our first step in Patran?
Geometry.
Geometry. Yep. And we're going to do nodes. So select XYZ. And let's see what we got. Actually, I have a little cheat sheet that gives me all the coordinates. Look them up. I think. Maybe not. Okay, I guess I gotta figure them out. Take them out. So, node 1. Okay, so you see on figure 3.4 how they drew the coordinate system. So node 1 is going to be what? 0, 40.